Educational Module Statistics for Data Science. Learning Unit Core. Use R to calculate and visualize descriptive statistics. Descriptive statistics help us present the information about our datasets, and in addition they can be the first step towards complex computations and analysis. Starting from the simplest descriptive measures, R provides the following built-in functions. The maximum value in a data object is found with function maxx, where x is the data object. We can optionally also use the argument na.rm equals true to remove any na values from x if we keep n as they are considered the largest values. Since the default value for na.rm is false, we can use maxx if we want to keep the na values, or if there aren't any in x analogous to maximum, R provides the minimum x. If there are missing values, na is returned unless na.rm equals true is used. R provides also the function length x to return the count of vector elements. This function by default includes the na values. Note that na.rm equals true/false does not work with this command. To sum up all the values vector elements R offers function sub x, and here also we can set na.rm equals true. The most commonly used measures for central tendency include the mean, the median and the mode. Mean is the average value. It's sensitive to outliers. In R the mean is computed with function mean x, and we can also set the value of na.rm to either true or false. Median is the middle value in the data set. It's a robust alternative to mean. In R the median is computed with function median x and can set argument na.rm as well. Mode is the most frequent value. In R the function mfva, which is included in the modus package, can be used to compute the mode of a data set. In this screenshot below there are some examples of calculating measures of central tendency. For the examples we use the iris dataset, which is packed with R and is readily available. This data set for measurements for 150 flowers representing 3 species of iris cerisa, versicolor and virginica. To get a quick view of the data inside iris, we can use the head function and define how many of the first rows we want to see. Then, we call the mean function to compute the mean value of all rows for column petal length. Next, we calculate the median value and then the minimum value from column sepal width. Last, function range is applied to column petal width and sepal width and returns the minimum and maximum values therein. The summary function can be used to display several statistic summaries of either one variable or an entire data frame. The output of summaries depends on the object we give as argument. When applied to a single vector, 5 values are returned: the mean, median, 25th and 75th quartiles, minimum and max, in one single line call. When applied to a data frame, then it operates on a column basis. The format of the result depends on the type of the data contained in the column. For example, if the column is a numeric variable, mean, median, minimum, max and quartiles are returned. If the column is a factor variable, the number of observations in each group is returned. In this example we see how we can apply the summary function to a column of a data frame and calculate minimum, first quartile, median, mean and third quartile, and max. We can also use the summary function to calculate same information for an entire data frame. In this case R returns in a column-like arrangement the 6 values under the respective column name. Note that in the case of columns that are of type factor, summary computes the number of observations for each factor level. R supports the more general-purpose quantile function, which follows the syntax you see on this slide. In this syntax, probs allows us to select one or several quantiles to display. If we want to work with quartiles, that we should use CQ0, 1, 0.25, which is the same as C0, 0.25, 0.5, 0.75, 1. Names tells R if it should display the name of the quantiles produced, and na.rm equals true tells R to remove any na items in X, otherwise we will get an error. The variance represents the average squared deviation from the mean. The standard deviation is the square root of the variance. It measures the average deviation of the values in the data from the mean value. For these two measures are offers functions var and sd respectively. The median absolute deviation MAD when given a set of values measures the deviation of these values from the median value in the set. We show the functions R provides for calculating measures of variability, and it is interesting to see which of these measures are often used and in which situations. For instance, range is not used very often because it is sensitive to outliers, and variance is also very rarely used because it is completely uninterpretable. The IQR is robust to outliers and is used a lot in combination with the median. The standard deviation is often used in the situation where the mean is the measure of central tendency, while the median absolute deviation offers a robust to outliers alternative to estimating the standard deviation. In this example, we call the quantile function on the cycle width column to compute minimum, max and the three quartiles. It is also very simple to compute the IQR. All we need to do is to give the IQR function the column we want as argument. Next, we compute the variance of column cycle width and next, its standard deviation. Last, we compute the median of the cycle width column and then the median absolute deviation. The apply function enables applying a function to the rows or columns of a matrix or data frame. The purpose of apply is primarily to avoid explicit uses of loop constructs. Apply family functions can be used for an input list, matrix or array and apply a function. Any function can be passed into apply. Depending on what function we specify when using the apply command, either a vector or a matrix is returned. The apply function takes as arguments the matrix or data frame, the margin that takes as values either 1 or 2 and the name of the function we want to apply. If we set margin equals 1, then that function will northeast applied on rows, otherwise on columns. As we already said, the apply function can be used to apply a function to a matrix or a data frame. The lapply function is similar to apply, but it takes a list as an input and returns a list as the output. The sapply function is the same as lapply, but returns a vector instead of a list. The tackly function computes a measure mean, median, minimum, max, etc., or a function for each factor variable in a vector. It is a very useful function that lets you create the subset of a vector and then apply some functions to each of the subset. And the mapply function is a multivariate version of sapply. It will apply the specified function to the first element of each argument first, followed by the second element, and so on. In this example, we can see how to use the mapply function to calculate the vector with the sum of the first elements in A and B, the second elements, etc. Here we see how we use the apply function to compute the sum of all values in each column of a matrix. The fact that we will work on a column basis is determined by argument 2. Next, we try the lengthly function on a vector containing 3 string elements in uppercase. We use lapply to apply function to lower on all vector elements. In this example we see how we can create a list containing 3 vector elements and then use the sapply function to compute the median for each vector in the list. Then, we try the tapply function on a data set in the datasets library included in R. In this unit we talked about the basic functions for descriptive statistics supported by R, such as minimum, max, etc. We also presented functions that calculate measures of central tendency, such as mean, median, etc. We discussed the summary function and functions for measures of variability. And we also discussed the apply function family and how they can automate calculation of statistics on data structures such as vectors, lists or data frames.